So good morning, everyone. Good evening, good day, whatever it is, the timeline. This is Harita Kasturi from PACE, Hyderabad. Today we are going to discuss about a few questions on thermodynamics and thermochemistry NEET, right? So all these you can check down. All these questions are very important to go with your NEET syllabus, definitely, and also base levels, definitely of your MSET syllabus also. Right? So these are very important to go with. So please go through these questions and come up to me with any doubts if you have. All right. So let's go with your first question there. Yes. So for the first question, what we can go here is for the reaction C3H8 plus O2. This is a combustion reaction of propane, right? So you're given an equation at a constant temperature. You're asked about delta H minus delta E, right? What is the formula for delta H? Delta H is the heat enthalpy in the system. Delta H is equal to delta U plus delta NGRT, and NG stands for the number of gaseous moles. So don't consider the liquid state of it. So delta NG here will be 3 and then -1, -6, -5. So that would be -6 totally for the left side. See, this is 5 moles and this is 1 mole. So it is 3 minus the left side, product side minus the reactant side, 3 minus 6, which is -3. So which we get here as delta H, and you are asked about delta H minus delta E. So delta H minus delta U, bacha, delta U is nothing but your delta E. Delta U internal energy also is equal to L delta E. Sometimes you represent it in U and sometimes you represent it in E. Only the notation differs. Equals to, how much is that? So that would be -3, and because delta NG is -3 and RT. So -3 RT. Option C is the answer here. Next, coming up for the second question, consider the reaction carried out at a constant temperature and pressure. If delta H and delta U are the enthalpy and internal changes for the reaction, which of the following expression is true? Here also, since you are asked about delta H and delta U, definitely go with the same format. Delta H is equal to delta U plus delta NGRT. All of them here are in gaseous state. In this equation, delta NG gaseous state stands for 2 minus 4, right? This is 2 minus 4. Right side product, products, minus the left side moles. Right side product moles is 2 minus left side here is 1 mole, and here it is 3 moles. Total you have 4 moles, right? So this would be -2 here. Delta Ng is -2. So I can rewrite this equation as delta H is equal to delta U plus of -2 RT, no? So which is -2 RT. You're subtracting something from delta U, then you get delta H, which means delta H is greater, delta U is greater, right? Which means delta H is less than delta U. Clear? Delta H, you may say you subtract something, then you get delta H, which means delta U is greater than delta H, which means delta H is less than delta U. So that is how you can go with your second question. Going with the same format, see, if you are thorough with a few formulations, I think you are good to go with your reactions. Any kind of questions, what you get, just go by your concept. As you go with the next question, 53, assume each reaction is carried in an open container for which delta H is equal to delta E. Again, the same. What you should do, always go with delta H is equal to delta E, or delta U also you can take, plus delta NGRT. Now you said delta H is equal to delta E, which means only this much. This part has to become 0. If this has to be becoming 0, delta Ng should become 0, which means total moles on the right side should be equal to the total moles on the left side. Option D is your answer here. 2 on the right, 1 and 1. 1 plus 1, which is 2 on the left. Yes. So delta Ng has to be 0 for this equation to be right. I hope you get that well. Yes. Move on with the next question, 54. Now, Which for the reaction, which of the following statement is true? Again, the same. Okay. Delta H is equal to delta U plus delta NGRT. All of them in the gaseous state. What is delta NG? Is right side moles minus left side. Right side is 1 minus left side is 1 plus half, which is 1.5, which is 3 by 2. It is 1 minus 3 by 2 minus half. So when I substitute it here, delta H is equal to delta U minus RT by 2 minus half of RT. Na? So you're subtracting something from your delta U, then you get delta H, which means delta U is greater than delta H, which means delta H is less than delta E, right? Next, U and E are same, bacha, remember that. Next, number 55. Enthalpies of the elements in the standard states are taken as 0. Yes, whatever element in its standard state, the enthalpy of it is 0. Always remember that statement, right? And the enthalpy of formation of a compound is always what? It can be positive or negative. Bacha, an element is formed when it can be positive or negative, because that element can be of the gaseous state, liquid state, or your solid state, whichever it is. So it can be positive or negative. It is not fixed, right? But the element in its elemental state, if I say, then yes, definitely it is 0. Next, if enthalpies of formation of C2H4, CO2, and H2O, all of these are given to you at 1 atmospheric pressure, are given to you this way, the change in the enthalpy is equal to given to you. So C2H4, do you understand this relation between these numbers, these elements, bache? Please try to get that relation here. What we have to talk about here is C2H4. This is called as a combustion reaction going on. If you observe it carefully, combustion C2H4 plus O2 will give you CO2 plus H2O. This is what is your combustion reaction. Please balance it also. Plus two carbons here, 2 carbons done. And then hydrogens 4 you have, put a 2 in front of this. Here it is also balanced. And here enthalpy is 0. Oxygen in its pure state, in its elemental state, the enthalpy is 0. That's the reason it is not given to you. Don't worry about that. If it is not given, please take it as 0, because oxygen ka enthalpy in its elemental state. See, the enthalpies of elements in their standard states is taken as 0. That is the concept we are using there. Yes. Same going with now water molecule is formed. Anything which is formed, the enthalpy is negative, because formation, two things come up together, then it has to release a lot of energy. Formation is always your negative, and energy is released, taken as negative in chemistry, and breaking down is taken as positive. Bacha, remember that part. And going by that, if it is C2H4 and this, so just go by your equations there, put on your these things. 2 carbon dioxide are made. Carbon dioxide, where is carbon dioxide? This is A, B, and C, I say. So this is A, B, and C, just for us to easily pick up the numbers. Huh? Okay, 2 times carbon dioxide is formed, which means 2 times of minus 394. Formation is minus 394, kada? Right? And H2O is formed, which is 2 times of minus 286. And then your A part, which is your C2H4. C2H4, it is 52, right? So here enthalpy of formation of C2H4 is 52 given to you. Please make it sure. Formation of C2H4 is 52, but we are not seeing the formation of C2H4. We are seeing the breaking down of C2H4. So it has to be minus 52. So all this when you do, you are going to get minus 1412. All right, so just do the calculations and see minus 52 minus 2 times this minus 2 times this. You are going to get it as minus 1412. So please pause it, do the equations, and then let me know about your doubts if you have any on this. All right, next, moving on with the next question. 57 here. Yeah, 1 second. Enthalpy change for the reaction does not depend on what? It does not depend on use of different reactants for the same product. No different reactants for the same product. It matters. Reactants matters a lot, right? So nature of intermediate reaction steps, yes, it does not depend on that for sure. Differences in the initial and final temperature involved, yes, it matters, because enthalpy is how much is the initial temperature and how much is the final temperature matters a lot for the enthalpy. Physical states of the reactants and products also matters for the enthalpy. Different reactants use or for this getting the same product also matters for the enthalpy, because whatever we are using, that has to be broken down to make up the other. So whatever reactants you are using, that will matter a lot. So the only thing which is not going to matter is the nature of the intermediate reaction steps. Whatever is the reaction steps, your physical states and all matters a lot. So, and then 58, on the basis of thermochemical equations 1, 2, and 3, find out which of the algebraic relations will give this. So how do we do that? We will be going with our same here, equations. We are given what? Delta C of graphite is given to us, and second one is graphite plus half O2 will give you CO. Carbon monoxide is given to us, and carbon monoxide plus half O2 will give you CO2. Here it is X, here it is Y, and here it is Z. So what is this? If you can see here, two equations, if you add up, you will get up the third one. See, if I say Y plus Z, if I add, what am I going to get? Tell me, Y plus Z. If I add Y plus Z, when I add these two, definitely this is half O2 plus half O2. It is 1 O2 plus carbon monoxide here. Okay, will give you carbon monoxide plus carbon dioxide, right? 2 and 3 equations I am adding up to get this. Now here carbon monoxide goes off, which means I am left out with C plus O2 will give you CO2, which is nothing but my first equation, which means X plus second and third, when you add up, you are going to get first, which means Y plus Z is equal to X, right? Clear on that, bache? Yes, shall we move on? So in case you don't understand, please pause it and come back to it. All right, I am moving on here. Next question, moving on. Yeah, 59. Given that bond energies are given to you here. Yeah. Oh, yes. Now, coming up with this, bond energies are given to given to us, hydrogen, chlorine, and 430 and all. See, these are the things given to us. Find the bond enthalpy of HCl. What do we mean by that? How is HCl formed? HCl is formed from H2 plus Cl2 in its elemental state. So balance it also, half of this and half of this, kada, right? It is only HCl, so half of this plus half of this. And hydrogen to hydrogen bonds are broken down. Hydrogen to hydrogen, it is 430. So half of 430, since the bond is broken down, it is positive, plus chlorine, half of 240. And then what? Then your some number, some value X, we don't know. Okay, that is your HCl. How much is the HCl asked, right? So see, if you can check this out, HF formation of HCl is minus 90, they said, right? Bond enthalpy of HCl is how much? We don't know the bond enthalpy of HCl. That let that be some X there, right? And formation of HCl is 90. So minus X is equal to minus 90. This is what we can write. So X value goes there, minus 90 to the left side. Is that clear? Bond enthalpy of HCl, hydrogen and chlorine, how much is that? We don't know. It is formed. So HCl is formed. That's the reason I have taken it as minus X. The total of it, answer is minus 90. It is being told. So from here, you will solve the X value. You will get the answer as 425 kilojoules per mole. That is what you get. Next, question number 60. Bond dissociation enthalpies of H2Br2. Same again. See, question number 60 also same. Okay, we'll do it again. Now, coming on to the same thing, H2 and Br2. So I would write it as H2 plus Br2 will give me HBr. So again, balance this, half of this plus half of this will give me HBr. Okay, bond dissociation enthalpy of H2. This is A and B, I would say, and C. So this is A, B, and C. Hydrogen is formed, so half of 434. And hydrogen is broken down, right? Half of 434. And then plus half of how much is bromine? Bromine is formed here. Bromine is 242. Okay. What is it as respectively? Enthalpy of formation of HBr is what? That is what is the total thing it has been asked to us. So minus HBr is being formed there. So HBr is formed there. So minus 431. So all this answer is going to be the answer there for you. Please check it out. You will get minus 93 in case you do it and check. All right, move on. Next question. Next question, question number 61. 61, let me first erase this, bacha. 1 second. Keep working out now. Yes. So let's talk about question number 61 here. The following are the two reactions, are some reactions given here. Okay, I'm just expanding this 1 second. Yeah. Right. So you are given some reactions, bache. Your 1, 2 reactions given. The value of delta H for the following reaction is how much? How is that we are going to get that equation? Please tell me. Okay, see, this is carbon dioxide and carbon dioxide. We want only one carbon dioxide. Shall I subtract this from there? Right. So first equation minus second equation. How about that? Tell me. When I subtract them both, if it becomes Fe2O3 minus FeO, and this will be plus 2CO, right? Will give me, because this minus this, the plus 2CO will give me 2Fe minus Fe is Fe. Oh, we can subtract 2 times second equation, then. Because we don't want Fe in this equation. See, please note this. We don't want right side Fe at all in the required equation. So all this Fe has to be broken down. So I would subtract, I'll do one thing, first equation minus 2 times the second equation. Let's do that. Then it gives you, right? So this is my first equation. This is second equation. First equation minus 2 times the second equation. So this is 2, this is 2, this is 2, and this is 2. So I'm subtracting this. So what happens here? This goes off. Then my equation is Fe2O3 plus CO. 3CO minus 2CO gada CO. And then minus 2 FeO will give me 3CO2 plus minus 2CO2 is CO2, right? Now this minus 2FeO to the right side. So Fe2O3 plus CO will give you CO2 plus 2FeO. This is what the required equation. So first equation, we will just focus on only this much part here now. So this is the first equation is minus 26.8 minus 2 times the second equation is minus 16.5. Now you work out on this, that will give you the answer. It has to be 6.2. Once you calculate it, you will get that, bacha. Okay. So in case you don't understand, please pause it, go back, and then come to me. In case you still don't understand, please get back to me. Our motto is to find the third equation. To find the third equation, Fe has to be removed. So I have been working out on those ways wherein I can remove my Fe, right? So that's how you have to think out. All right, moving on to the next question. Consider the following process. Okay, so here the process is about A turns to B, okay, B turns to C plus D, and something is given to you. We want for this, we want this much, right? We want E plus 2C on the right side. E plus 2C. E I can see on the left. This is my first equation, second equation, and third equation. E on the left side I can see, but I want it on the right side. So minus the third equation I would do from where? 2C, right? 2C is my second equation. So let me first check up how much is that I'm going to get. 2 minus 3. I'm subtracting is, then I would get what? 3B minus E minus A turns to this, my 2 minus 3, na? 2C minus 2D. It will be 2C minus 2D. and then plus D. So that's how much is that we are going to get it as here 3B. All this minus, I am taking it to the right side, bacha. 2D minus 2D plus D is minus D to the left side aa jayega. So plus D will give you E plus A. Right now, what is that we want? E I got on the right side, and 2C also I have on the right side, and B plus D I want. So here I have it as B plus D, but I have it as 3B and all. So what is that we have to do now? I would just add second equation, sorry, 2 times the first equation I would do. See, 2 times the first equation, if I do, what is that I get? 2 times the first equation is A gives you 2B. Oh, no? Now I am just solving these two parts. So what is that I get here? Now this is 3B, this 2B to the left side, 3B minus 2B, wo B ban jayega, plus D, right? And A on the right and A on the left cancels out, will give me E plus 2C. So what is that we have done? So plus 2 times the first equation also we have done. Second equation, so I would just copy down these values now. Second equation is minus 125, minus third equation value is 350, plus 2 times the first equation, which is 150. So when I solve this, you are going to get it as somewhere around minus 175, option B there. So from the given equations, try to bring up your required equation, and that's it, you're there. All right. Moving on for the next question here. Yes. Annotate, come on. Clear. Oh, yes. Next. Delta H of formation, something is given here. Delta H of formation of CO2. Okay, I would just name these as A, B, and C, Nana, so that it becomes easy for me to go with. This is A, B, and C respectively. Standard enthalpy change for the reaction. So this is the reaction given to you. Hydrogen ke liye 0, because hydrogen in its elemental state, it is 0. So carbon dioxide, this is heat of formation of carbon dioxide given to you as minus 393.5, but we want breakdown of carbon dioxide, so it is 393.5. and carbon monoxide, hydrogen का तो 0 हो जाएगा, okay, plus 0 डाल देती हूँ, and carbon monoxide is formed. Carbon monoxide is B value. B value is this, formed, which means minus 110.5. Formed, which means the energy is released. Okay, and water molecule formation is minus 241.8. Once you solve it, you would get the answer 63. The answer would be option B. Check it out. All right, move on. Then, if the enthalpies of formation of this is A, B, and C are, this is A, B, and C, the change in the enthalpy is equal to, same question, I guess we have already done this question. I think there's a repetition in the question. I think the first prior question, somewhere around 56th question is the same. Okay, so if you would have done the 56th question, this is the grace mark there. All right. So anyways, so I want you to try it again. All right. Without my presence, I want you to try them all. All right. So next, move on with the next one, which is an intensive property and extensive property. Intensive is independent, extensive is dependent. Which is dependent on the mass. Dependent on the mass. What are dependent? Definitely volume is dependent on the mass. Viscosity is independent. Temperature is independent. Please write down independent. This is intensive, and refractive index is independent. Volume is extensive. Okay. Next, which of the following is an example of extensive property? Which is extensive property? Your mass is definitely extensive property. That definitely depends on the mass. Pressure is force upon area. Pressure, whatever is the force applied by that molecule, will not change how much ever the mass of the content is. So this is, pressure is intensive, density is intensive, temperature is also intensive. They do not change with that, mass in it. So independent. Mass is extensive property. Next, going on with the next question here. All of these are, see, check out. So these are all theory based, your concept oriented things. Bacha, please be very, quick in your questions, because you will not get so much of time. NEET specially, you have to be very, very fast, because you have to attempt 50 and 50 questions of physics and chemistry, 45, 45, I mean, which is still a big number to go with. Yeah. Now pick out the wrong statement. Which is your wrong statement? Standard free enthalpy of formation of all elements is zero. We just now have discussed any element in its free state formation is always enthalpy zero. Process accompanied by decrease in the entropy is spontaneous under certain conditions. Yes, decrease in the entropy, which means delta G is equal to what? Your delta H minus T delta S, decrease in the in your entropy. So delta S is lower, then obviously temperature is the one which is going to decide if it is positive or negative. So if you have a negative value for G, then it is spontaneous. So definitely under certain conditions, right. Then entropy of a perfectly crystalline substance at absolute zero is zero. Yes, if it is a crystalline substance at absolute zero, the entropy will be zero, definitely. And the process that leads to increase in free energy will be spontaneous. No. Increase in the Gibbs free energy, which means delta G positive, which is non-spontaneous. So here it says spontaneous. So this is the one which is your wrong statement. So option D is correct then. Option D is the wrong statement out of all these things. So please be thorough with your statement questions, also very important. Next, moving on with 68, identify the correct statement for the change of Gibbs free energy of a system, delta G at a constant temperature and pressure. Correct statement पूछा है, delta G of a system is zero, which means system has attained equilibrium. Khatam kahani. That's the best question, yeah? So delta G is equal to zero, it is equilibrium. Delta G less than zero, spontaneous. Delta G greater than zero, non-spontaneous. Delta G of the system is zero, system is still moving in particular direction. Not at all, not at all, not at all. Right? So option A is right. All right. So be very clear, Nana. Please be thorough with your concepts, because the concept is going to take you further, not your formula sheet. Okay. Next, moving on with the next question here. 69, I guess. Yeah. 68 done, now 69. So identify the correct statement regarding the spontaneity. What is the correct statement? So 69, lowering of energy in the process is the only criterion for spontaneity. No, why no? Because lowering of things is what? Delta G, we know the formula, right? Delta G is equal to delta H minus T delta S. Lowering of energy in the process, which means delta H negative ante, it is the only criterion for the spontaneity. No, in case if it is spontaneous, see delta H negative, 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 negative only. But in case the delta S is also negative, then what happens? So it is not the only criterion. In case delta S is negative, negative of negative, positive అయిపోతుంది, and your delta H negative, this part positive. In case your delta S is more positive, then definitely delta G will be positive. Then your answer is not spontaneous. So here the option is wrong. All right. So it is not always the only criterion. Next, for a spontaneous process in an isolated system, change in entropy is positive. Spontaneous process, isolated system. So change in entropy positive unte. If see, imagine this is positive. Delta G is equal to delta H minus T delta S. This is positive. Change in entropy positive. Plus of minus is minus. And isolated system के लिए change in del Q is zero implies, can I say delta H is also zero, heat change is zero, so this is zero, zero and negative value, the answer is negative, so delta G is negative, so option B is right. Spontaneous, for a spontaneous process, isolated system, Q, change in Q is zero, change in the heat content is zero, right? So change in the heat is zero, therefore heat content in the system change is zero. So this is zero, delta is positive, negative of positive, negative, khatam kahani, your answer is negative. Answer is negative, which means delta G negative means that it is spontaneous. So rest all are wrong then, right? Then chemical reaction will be spontaneous if it is accompanied by a decrease of what? If it is accompanied by a decrease of free energy of the system. Free energy matlab Gibbs free energy, bacha. Spontaneous if Gibbs free energy is less than 0. Remember that. Decrease of pucha hai, to definitely Gibbs free energy. Not to worry about any of the other questions at all here. All right. Moving on with the next question. Yes. Question number 69. Identify the correct statement regarding the spontaneous process. Lowering of energy. See, whenever you see about the spontaneous, non-spontaneous, just go for this formula. Delta G is equal to delta H minus T delta S. Lowering of energy in the process is the only criterion for the spontaneity. It is not the only criterion for a spontaneous. Oh, this we just have discussed. Sorry. Yeah, question number 70. Next, a chemical reaction will be spontaneous if it is accompanied by a decrease of free energy. This also we have discussed. Next, 71. In which of the following entropy decreases? Crystallization of sucrose solution. See, crystallization, which means liquid turning on to solid state, which means random state, you are moving on to a stable state. Okay, so decreasing of randomness. Decrease of randomness is decrease of entropy. So entropy decreases here. Okay, are you getting me? So anything which is slowing down, which is changing the state from a more free state, I mean from a gaseous to liquid, liquid to solid, then you are moving into a stable state. So then entropy decreases. Next, here see melting of ice, solid to liquid, kada. Solid to liquid, liquid is more randomness, right? Molecules are more randomly moving, said more randomness, more disorderness. So therefore, entropy increases there. So it's goes like that. Same like vaporization of camphor also, solid to liquid, right? And rusting of iron, it flakes away, right? So it eats away. So more of randomness, oxidation happens there. So more of randomness happens. So it is not. So entropy decreases in crystallization of sucrose to sucrose solution, liquid to solid, which means you are coming into a more stable, rigid state. Okay, so randomness is decreased, and entropy is a measure of randomness. So that will be decreased here. Next, 72. Spontaneous reaction is impossible. Is impossible, pucha, so impossible or possible, go with the same formula again. Both delta H and delta S are negative. See, delta H negative, delta S negative ante negative of negative, positive here. So negative and positive, it definitely depends on the temperature. In case that it is impossible and chappalemo, it can be possible also. In case if your delta H value is negative, definitely in this positive value. In case your value of delta H is highly negative only, then it will be happening. Na? So it is completely possible, impossible, and Japalam. That is not wrong. So then both delta H and delta S are positive. So both option B ke liye both are positive. Delta H is positive and delta S is also positive. Positive of negative is negative. So then definitely it depends again on the temperature. If temperature is more, then negative more, then the reaction is possible. So we can't say that as well. Next, C, H is negative. H is negative, delta H negative, and delta S is positive. Delta is positive. Positive of negative will be negative. So reaction is possible. Option C, reaction is possible. These two depends, right? Whether it is positive or negative depends on the temperature. C is always possible. Next, D, delta H is positive. So delta H is positive and delta S is negative. Negative of negative is positive. Two positives, delta G is positive, which is definitely non-spontaneous. So this is impossible, definitely. Okay, next, moving on with the 73rd question there. For the gas phase reaction, PCl5 is decomposing to PCl3 and Cl2. Same again, which of the following conditions are correct? Decomposition is asked to you. Definitely you are heating the system there. So delta H is greater than 0. So delta H is greater than 0. Option B and D looks fine. And delta S, this is also moving into a gaseous state, much more into a gaseous state. So delta S is greater than 0. This reaction is happening. So delta S is greater than 0. All right. So that is how it goes on with moving on to the next question. Clear. Yeah. 74, right? Yes. Now, with the 74, during the complete combustion of 1 mole of butane, 2658 kilojoules of heat is released. Okay, total one is this much kilojoules. And the thermochemical reaction for the above change is what? Pucha hai. So now, definitely what you should go is, see, heat is released unto null. If heat is released, your H2O, which has been in your gaseous state, now turns to your liquid state. So this, and this will be your answer. In these three, whichever is going well with your balancing part, please check out correctly. It is the same reaction, but balancing is the difference here. So if you check out, option C is right in the balancing part. Please check it out. Pause it and check it out. All right. Next, number 75. Given that heat of neutralization of strong acid and strong base is minus 57.1 kilojoules. Okay, so strong acid and strong base neutralization heat idi. The heat that produced when 0.25 moles of HCl is neutral. See, it is strong acid and strong base, HCl and NaOH, you are neutralizing 1 mole of it only. H plus and OH minus will give you 1 water molecule here. To neutralize 1 mole, you want minus 57.1 kilojoules for 1 mole neutralization. But here it is asked 0.25 moles of HCl is neutralized with 0.25 moles of NaOH, which is nothing but 1/4 kada. 0.25 moles is 1/4 of a mole. 1 mole ki minus 57.1 aite, 1/4 of that mole ke liye how much? So that would be 1/4 of 57.1 you do. You're going to get it as A, option A, 14.275. All right. Next, moving on with the next question. For most of the ionic compounds, delta H of the solution is dash. Most of the ionic compounds, okay, and the dissociation process is, see, dissociation process is always, I would say, endothermic, endothermic, because ionic compounds, they use heat to dissociate themselves into ions. So endothermic definitely. And as they are endothermic, they turn into more a random state dissociation. The compound is dissociated into ions and the ions move randomly. So their randomness is increased. So therefore, your heat content in the system is also positive there, right? So option C is right. All right. Moving on. Next question. Okay. Yes. Question number 77 now. All right. For a particular reversible reaction at temperature T, delta H and delta S were found to be both positive. Okay. Then if T of this is C, so positive at all these three, if I see now, I just blindly write down delta G is equal to delta H minus T delta S, right? So this is what you will write first. And what is that they said? For a particular reaction, T, delta H and delta S were found to be both positive. So delta H is positive, T is positive, and delta S is positive. Positive of negative will be negative. If TE is the temperature at equilibrium, if TE is the temperature at equilibrium, delta G is equal to 0. Now T stands for TE here, right? And the reaction would be spontaneous. When will the reaction be spontaneous? See, I would say T delta S, this is T delta S kada, delta H is equal to, so TE into delta S is equal to delta H. So TE is equal to delta H by delta S, I would write here. All right. And at what temperature this happen? At a temperature greater than the given temperature, right? Because otherwise positive and negative you have. So TE, so this thing has to be more. So your temperature greater than TE is required. So whatever temperature you have, that temperature should be greater than TE, so that here this all value is more bigger value. If it is more bigger value, then you will have your answer here as your negative. So only then you will get your value of G as negative there. Clear? Next, moving on to the next one. Which of the following pairs of chemical reactions is certain to result in a spontaneous reaction? 78. What is spontaneous reaction? Spontaneous, again, I'll go with the same formula. Delta G is equal to delta H minus T delta S. Spontaneous reaction ante delta G has to be definitely your more less than 0. And exothermica, endothermica, they are asking about. So I would say it has to be exothermic because heat content negative undali. Idi negative undali. And positive here, negative of positive will be negative. So delta S positive, because negative of positive, this term will be negative. Two negatives, the answer is negative. So delta S should be positive, which means increasing disorder. And your exothermic, which means delta H negative. So option A here. Next, moving on with 79, in which of the following reactions standard entropy change delta S is positive, and standard Gibbs energy change delta G decreases sharply with the temperature. So same again, you will go with delta H. Delta G is equal to delta H minus T delta S. Delta S positive, it says, okay, delta S is positive, and standard entropy change is positive, and Gibbs energy decreases sharply. So this is also negative, so which means your answer is spontaneous, your equation is spontaneous, and decreases sharply with increasing temperature. As temperature increases, see for your graphite bacha, see graphite, as your temperature increases, delta S is positive for graphite, because graphite, as the temperature is increased, moves to a gaseous state. Graphite is a solid state moves to the gaseous state. So it moves to the gaseous. Here it is solid only, which is no, entropy is again decreased. Option C, entropy is decreased. Option A, B and D, entropy is increased. But in that also, A and D are correct because it is graphite and graphite. Now you go with your balancing part well. So that will give you the answer. Option A is your answer here, right? So C plus half O2 will give you CO. That would be your answer. So carbon monoxide gas is released here. All right. Next, moving on with the next question. Clear all the drawings. Yeah, question number 80. At the sublimation temperature for the process, yeah. At the sublimation temperature for the process. Sublimation ante enti? Solid moving on to liquid. Solid moving on to gases. Solid to gas, your randomness is increased. Randomness is increased, matlab entropy is greater than 0. Delta S is greater than 0 here and here, right? Here also well. Okay, and sublimation is going on there. So delta H has to be greater than 0. Solid to gas, you are heating the system. Delta H should be greater than 0, definitely. And solid to gaseous state, there is a state change going on. Please observe that part. CO2 solid, CO2 solid to CO2 gaseous state. Whenever there is a state change, the system is in equilibrium, and equilibrium delta G is equal to 0. At equilibrium, delta G, Gibbs free energy, is always 0 at equilibrium. So be very sure of that. Okay, it cannot be less than 0, greater than 0, not at all. Okay, so I hope you get that. You are heating the system, delta H greater than 0, and the system turns from the solid state to the gaseous state. More of randomness it is moving on to, so delta S entropy is positive. Next, 81 we go. Choose the reaction with negative delta S values. So what do you mean by negative delta S value, bacha? Delta S value, please go with delta S is equal to Q by T. Q by T is move on with your delta Ng value there. Delta Ng kiska bhi negative hai. That's your answer. Delta Ng value here, it is 2 minus 3. Option C is right. Right? So delta, Ng value here, delta Ng is negative, definitely. All right. Next, question number 82. Which of the following statements are correct? It is saying. In case of expansion of maximum amount, expansion, okay, a gas is being expanded, the piston is moving upward now. Maximum amount of work can be obtained under isothermal conditions. Yes, isothermal, which means there is a heat loss, definitely expand ho raha hai, which means gases are expanding, losing their temperatures. Then the external heat also comes in, a lot of work is done. Yes, so in the case of expansion, maximum amount of work can be obtained by isothermal conditions, by reversibly carrying out the process, not irreversible. Irreversible is a spontaneous process, which are not irreversible. Reversibly, slowly you will do that, right? Next, in case of compression, as you compress, minimum amount of work can be done on the system by carrying out the process irreversibly. See, minimum amount of work irreversible lo jarugutundi because it is spontaneous. Maximum amount of work done in reversible processes. Both are right. Option A, 1 and 2 are right here, right? Next question number 83 there. Yeah. Read the following statements carefully and choose the correct option. The case of diatomic molecules, the enthalpy of atomization is also the bond dissociation. Yes, diatomic, which means H2. H2 lo atomization ante it leads to 2 hydrogen, which is nothing but bond dissociation. Yes, it is right. Right? Each bond, that bond is getting dissociated. Hydrogen to hydrogen single bond untundi, that gets dissociated. Then in case of polyatomic molecules, bond dissociation enthalpy is different for different bonds within the same molecule. Yes, because sometimes it is your single bond, or sometimes it is your double bond, it is your triple bond. Yes, the bond dissociation enthalpy differs for each of them. So both are right statements. Now, statement-oriented questions are very important in NEET. Not just for the NEET, it is very important for MCET and JEE mains, low-level JEE mains also. It is very, very, very important. Please be sure of them. Next, please be very fixed with your concept, very strong at your concepts. Now, moving on, 84, read the following statements correctly regarding the spontaneity of a process and mark the appropriate value. Let's talk about them. When enthalpy factor is absent, randomness factor decides the spontaneity. Yes, because delta G is equal to delta H minus T delta S. This enthalpy factor is absent here, which means delta S is the deciding factor. If delta S is positive, then minus of positive negative, then it will decide, then delta G will be negative, and delta G has to be negative for a spontaneous process. Next, when randomness factor is absent, the enthalpy factor decides the spontaneity. Yes, now in case this one, the second question is this factor is absent, then obviously delta H will decide. If it is exothermic, then the reaction is spontaneous, because exothermic, delta H negative. So negative implies delta G is negative, implies the reaction is spontaneous. So it will decide. When both the factors take place simultaneously, magnitude of both the factors decide. Yes, only the magnitude will tell us which is a greater value, either the positive value or the negative value. The more negative value you get, the more spontaneity you have, because delta G will be more negative. So options 1, 2, 3, all of them are correct. Option C is our answer there. Next, move on with 85. The enthalpy of fusion of water is 1.435 kilocalories. The molar entropy change for melting of ice at 0 degrees Celsius is what? So you will go with the same formula there of enthalpy, molar enthalpy. Yes. So 1.435 kilocalories per mole will be your enthalpy of fusion of water, right? At 1.435. Molar entropy change asked to us, entropy change for the melting of ice is. So delta S is equal to delta H by T, right? Or Q by T. Q is nothing but your heat content in the system. That would be delta H by T. And what is delta H is given to you as your enthalpy of fusion. That is nothing but fusion of water. The heat content there is 1.435 kilocalories दिया है तो 10 power 3 डाल दो by 0 degrees. 0 degrees is 273 Kelvin. So this answer, if you do, it is going to be 5.26. All right. So moving on, delta S is equal to delta Q by T or delta H by T. Here in this case, it is also delta U by T, Q by T. It's nothing but fusion of water, enthalpy of fusion. Okay. Next, moving on to the next one. Yeah, question number 86. Yes. Here, as you can go up with, there are a few questions based on the same things. Delta G is equal to the same thing. Okay, see, here it is given to you, question number 86. Delta H is negative. So delta G is equal to delta H minus T delta S. By now, I am sure that you all would have corrected your formulae well, right? Delta H negative, this is negative. Delta S negative. Negative of negative, which will be this one is positive. So negative of positive, this will be dependent, definitely. This will be what dependent on if the things are at low temperatures, because the second, term should have low value, temperature, low value, temperature, low temperature, low temperature. Now, low temperature, the reaction will be spontaneous. So, spontaneous AR. So, A is going with R. As you can see, AR, you have two options. Okay. BP and BQ, let us check up for that as well. Delta G is equal to delta H minus T delta S. B, delta H is negative. Delta S is also negative. Negative of negative, which is positive. And delta G positive, it says, which means non-spontaneous. Non-spontaneous, which means temperature high, right? At high temperatures, this reaction will be non-spontaneous. So it will be BP, right? So BP, option B is your answer there. So you will validate the other statements also, bacha. You will not fix it on with one statement. You will go with others also. Next, the value of enthalpy of neutralization of weak acid and strong base is numerically less than 57.1 kilojoules, right? Neutralization of weak acid and a strong base. Okay. Is the assertion correct? Yes, assertion is correct. New weak acid and strong base, this goes by some values of your equilibrium also. Let us not go with this right now, this question, because it's a combination question that you have got from. So let us not discuss that question. All right, I'm moving on with the next one. Yes. When a solid melts, decrease in the enthalpy is observed. So as a solid melts, tell me what happens. Melting down is absorbing energy, right? So decrease in the enthalpy, it says no increase in the enthalpy because it is absorbing. So assertion is incorrect. Assertion is incorrect. Option D, undoubtedly, option D. Here all assertion is correct. Assertion is incorrect. Reason, melting of ice is endothermic. right? Next, 89. Now, many endothermic reactions that are non-spontaneous at room temperatures become spontaneous at high temperatures. Yes, because temperature will be the defining factor, right? And which means assertion is correct. Okay, ABC, all right. Assertion, right? Then entropy of the system increases with increase in the temperature. Yes, definitely. As you increase the temperature, randomness increases, which means entropy increases. As the entropy increases for the endothermic reactions that are non-spontaneous room temperatures, become spontaneous at high temperatures. So assertion is correct. Reason is also correct. Reason is also correct, and reason is, correct explanation also. Next, an exothermic process which is non-spontaneous, it says, at high temperature may become spontaneous at low temperatures. Exothermic, which is non-spontaneous. Exothermic, which means energy is getting released at high temperatures. Energy is released at high temperatures may become, spontaneous. So as you see, question number 90, Vacha, and an exothermic process which is non-spontaneous at high temperatures may become spontaneous at low temperatures. Yes, because if it is not spontaneous at high, it will become low, because that, as we have seen, that same thing, delta G is equal to delta H minus T delta S. This temperature is the deciding factor. In case your delta H negative, and your delta S positive, positive of negative, negative बन जाएगा. But in case your delta S is positive, negative, in case this is negative, negative of negative positive बन जाएगा, then your temperature is the deciding factor, definitely. So yes, assertion is correct. And what about the reason? There occurs a decrease in the entropy factor as the temperature is decreased. Yes, as the temperature is decreased, molecules settle down and randomness decreases. Randomness decreases, entropy decreases. Yes, reason is correct, definitely, but not a correct explanation for that. Okay, the reason is not that. Reason is this relation, not this. So assertion is correct, reason is correct, but not a correct explanation. Option B is right there. All right. Next, there is exchange in the internal energy, right? There is exchange in the internal energy in a cyclic process. Internal energy is your delta U, right? Cyclic process, as you can see, internal energy. Any cyclic process, state change will be zero. State variables change will be zero, and your path variables delta Q and delta W will not be zero, right? So there is a change in the internal energy in a cyclic process. Yes, there is a change, right? So assertion is correct. Then what will be your other part? Let us check out that as well. Your reason part also, we will see. 1 second. Clear. Yeah. Cyclic process is the one in which the system returns to the initial state after a number of reactions. Yes, but the reason, yes, definitely, reason is also a correct explanation, because that's the reason, your internal energy is changed, but your state variables do not change. There is a change in internal energy. The path variables do change. Assertion is correct. Reason is also correct. Option A is right here. Option A. Then 92. Assertion. Internal energy is an extensive property. Tell me, is it an extensive property? Yes, it is extensive property. It is dependent on the mass. Internal energy is dependent on the mass. So definitely it is extensive property. Internal energy depends upon the amount of the system, right? Yes, how much ever is the amount of the system, that depends on it. Reason is correct, and it is a correct explanation also. Option B is correct. Reason is correct. Oh, reason is a correct explanation. Option A, not B, A. Next, match up the next one there. Let's clear it up. All this is a easy paper only, bacha. Please be good with your concept. You're done. That's it. Be fixed on your concept only, nothing else. Yes, question number 93, as you can see. H2 plus Br2, okay, something is given to you here. So first calculate the delta Ng here, gas, okay. Delta, because since the question is asked about delta Ng values on the right side, delta Ng is equal to 2 minus 2, which is 0 here, right? So which means delta H here. See, we know delta H is equal to delta U plus delta NGRT, right? So delta Ng is 0. So this part becomes 0. Delta H is equal to delta U. A stands with R. AR is right. Okay. This and this are wrong. Next, B. Second one, your gas, definitely. Delta Ng value is product side is 1 and 1. 2 minus 1, which is 1. So will be with S. B with S. Option B. Khatam kahani. Right? B with S. Please validate the rest all also. All right. Next, moving on 94. Here, enthalpies of atomization, formation, all these are asked to you, bacha. Please look at to this properly. A stands with what? Here, A stands with, this is what? This is combustion, right? C4H10 plus O2 will give you CO2 plus H2 and lot of energy is released. This is enthalpy of combustion. A stands with R. AR only in option C. That's it, your option C. The other ones also, please validate it. So what is B going up with? B is CH4 will give you C plus 4 hydrogens. Okay, which means you're having what? B is going up with enthalpy of atomization. Molecule is forming into atoms there. So enthalpy of atomization. BP is right. Then C stands with what? C stands with something, two elements, two substances are mixing together to form BR, HBr. H2 plus Br2 will give you HBr formation, enthalpy of formation. Then D, Na minus will give you Na. Which means what? Here it is going up with sublimation. Solid is turning into a gaseous state. Option D, solid to a gaseous state, then it is enthalpy of sublimation. I hope you're done with this, right? Moving on. Next, annotate. Question number 95. Yes. Yeah, piston filled with 0.04 moles, okay, N is equal to 0.04 moles, expands reversibly from 50 ml to 375 ml. Delta V is equal to 375 minus 50, this is ml. So by 1000 we dal do at a constant temperature of 37 degrees. So temperature will be 273 plus 37. So which will be 310, 300, 310. 310. Then as it does so, it absorbs, which means absorbs this much of heat. Q is equal to 208. Absorption is positive. The values of Q and W. Positive 208 is the answer there. Q is equal to positive 208. Option B wrong. Option C wrong. So here it is this and this, right. Now your work done. Work done is PV delta T, right? So just go on with that, right? Work done is equal to P into V, or PV is equal to nRT. Just go attack on that. You will get the answer there. Next, question number 96. As doing so, you would get minus 208 there, because it is work done is what? Minus or positive? Tell me, because see, here only you don't need to do anything. Here the gas is expanding, right? 50 ml to 375 ml. Options dekho, plus 208 and minus 208 are the only options left with you. So gas is expanding, which is work done by the system. If the system is doing work, then work is negative. So option A will be right there, right? You don't need to do the calculation also here. Right, moving on 96, according to the first law of thermodynamics, delta U is equal to Q plus W. In special cases, the statement can be expressed in different ways. Which of the following is not a correct expression? See here, Q is equal to minus U when delta U is 0, when change in internal energy is 0 there, right? Which means a cyclic process. Cyclic process, delta U becomes 0. Any state variable change will become 0 there. right? When no work is done, then delta U is equal to Q. Very good, right? In a gaseous system, which is not correct. Now, okay, these two are correct. Then in a gaseous system, delta U is equal to Q plus P delta V. Yes, work done is equal to PV. Yes, it is right. Then when the work is done by the system is doing the work will be negative. Option D is wrong. Right? So option D will be your answer there. Option D is wrong, which is a wrong statement, not a correct expression. So option D. Next, internal energy change when a system goes from a state A to B, 40 kilojoule per mole. A to B, 40 kilojoule per mole. If the system goes from A to B in the reversible path and returns to the state A by a irreversible path, what would be the net change in the There is a difference in the path, which means path functions do change, which means what? Q and W is not equal to 0. But change in the internal energy is asked to you. That is a state variable. Change in the internal energy is 0. Undoubtedly, it is 0. You don't need to work on it at all on any cost, right? So that is how please do your questions carefully using your concepts, okay? And be ready with these because I am going to take a test on this as well next class, coming up class, all right? Be prepared. And I want all these things to be in your notes for sure. All right. Bye bye, bachas. See you. Take care. Any doubts that you have, you will come to me on this. All right. Bye bye. See you. Take care.